Hi everyone. In this video, we are going to discuss about Kubernetes architecture. And today is the day we are going to start Kubernetes playlist. So in the future, you will receive all the Kubernetes related videos in this channel. So let's discuss about Kubernetes architecture first, and we can discuss about all the components and usage as parallel. So when you heard about Kubernetes architecture, Kubernetes architecture do come up with the master and slave architecture. So I would like to draw a diagram, and I would like to take you through all the components in the entire Kubernetes architecture. So let's consider that we have one master, one worker node. So this is a master node, and here we have a worker node. So in architecture, it's a combination of components in a Kubernetes. So usually in a master nodes we have a set of components, and in a worker node we have a set of components. So this is a master node, and this is a worker node. So let's discuss about the components are present in master node. So the first one is API server. So I'm going to write it down over here. This is the API server, and second one is the controller, and third one is the scheduler. And fourth one is etcd database. So these all components are present in master node in Kubernetes architecture. And let's go to the components that are present in a worker node. So the worker node has a set of components. The first one is kubelet, and the second one is kubeproxy, and third one is container runtime. It may be any container runtime. We have a number of container runtimes are present in market. So these all components are present in our master and work node. So we have around 7 components are present in Kubernetes architecture. So let's discuss about each one individually, and let's discuss about deep dive into each component. So I'm going to choose the first one is a master node components, and later I will go with the worker node components. So first one is the API server. So API server, I can say it's a crucial and most commonly and most importantly used component in Kubernetes. So if you want to get authenticated with the Kubernetes cluster, so first you will talk with the API server. And internal, all the components do communicate with the API server to make the job done. So that's the beauty of API server, which means you take the request from the user and you talk to other components, and it make the task to be done. And it do communicate with all the components that are present in master node and worker node. So in our case, we have one master node and another worker node. So usually in industry, we may have a number of worker nodes, and we have multiple master nodes too, based on our requirement. So that's the usage of API server. It just get authenticated with the user, and it take the inputs, and it do talk with other components. So we'll discuss about how API server do communicate with other components. So let's just keep in mind API server. It's a kind of server. It take the responsibilities from, or take the task from the user, or it get authenticated by the user, and it make job to be done. So that's the API server component usage. And controller. So I can say that controller is a component that, an ideal, I can say it's the brain of all the Kubernetes architecture. Because of controller is the thing, controller is a component that do monitor all the components that are present in Kubernetes cluster. Usually when you heard the Kubernetes, so Kubernetes come up with a pods. It's kind of isolation place to be used in Kubernetes. So pod is pod used to run your containers. So we may have a number of runtime containers. We can use it. That's why Kubernetes came up with the ideology, or the isolation place where you can use for any number of runtime containers. So that's why we use a pod. So the usage of controller, it do monitor all the resources or objects that are present in Kubernetes cluster, whether it is of a pod or deployment or replication controller or replica set or namespace controller, or we have a persistent volume controllers. So these are a set of objects that we have present in Kubernetes cluster. So the main uses of controller is just to monitor all the objects that are present in Kubernetes architecture, and to take the inputs so from the API server, and what was the desired value and what was the expected value as an actual value. So it just handle all those inputs, and to take to monitor all the objects that are present in Kubernetes cluster. So that's the usage of controller. And what does that mean by scheduler? So as I mentioned, so whenever we get the request from the user, so it comes from the API server, and the API server do pass the request to the scheduler, and scheduler take the responsibility, and it will find which node has a set of resources to be, and let's example, this node has a 10 GB of RAM and 15 CPU. So scheduler is going to elect whatever requirement has came from the API server, and it will take that requirement and it will see which node is suitable for scheduling a particular task. So that's the usage of scheduler. And etcd directory. So this is one of a component present in our Kubernetes architecture. So etcd used for storing your data of all your master and worker nodes, and this data do store in key and value pair, and it's a non-relational database, or I can say that NoSQL, and it do store in document format. So what does that mean? Because of if whatever activities that are been happening in Kubernetes, so it do store in this particular place, then only we can say that what all things happening in a Kubernetes cluster, and the Kubernetes cluster get to know, okay, these all are things or these all activities are happening inside of a cluster. So these all components are present in master nodes. And let's discuss about the components that are present in worker node. The first one is a kubelet. So on the other hand, I can say kubelet is a captain of the worker node. I can say this is a master. It take all the responsibilities from the master node, and it act as the captain of this node. And the responsibilities may be creating a pod, or giving information of all the pod to the master node. So that's about the kubelet. And just keep in mind, kubelet is going to work as a captain of all these node, and it has all the command lines of the worker node. So that's about the kubelet, and let's discuss about the kubeproxy. So kubeproxy is a component, so it enables traffic to your pod from the service, and if you have a number of services in your Kubernetes cluster, so it take that it enables the service from one pod to another pod, make it happening in between the conversion or in between the communication. So that's about the kubeproxy. And the next one is a container runtime. So why we have mentioned container runtime? Because Kubernetes supports a number of container runtime. So in industry we have Docker, we have a Containerd, and we have a Rocket. So we have a number of container runtimes. So by utilizing or by installing container runtime, so we do create a container inside of the pod. So for that reason, we need to have one software has to be present in container runtime in a particular node. So that's about all the components and usage. And let's discuss about how these components do work in between and taking the responsibilities from the user. So let's example, there is a user, here user. We can consider it is a user or developer, whatever it may be. He's a user. And first what he do now, if he want to communicate with the cluster, so he just do authenticate with the API server. It is API server. And he pass it off, username and password, or if you enable a certificate, so it just authenticate with the certificates. And once he communicate with the API server, first he said that I want to create two pods, and with each pod has one container. So that is his requirement. So this is the requirement, and developer has said to the API server, and API server do take the responsibility to make it is enabled, and this is the desired value, and two pods, and each pod has to contain one container. So this API server is going to talk to the first is a scheduler. So he's going to talk to the scheduler, saying that, hey, scheduler, I got the request from the user our developer saying that he wants to create two pods, and each pod has one container inside. So what scheduler will do? It will take the responsibility and it will contact through the API server to the particular worker node. So he will go back to here and it will talk to through the API server with a node. So first what it will do, it will check whether this particular node has a proper resources, which means like does it have a resources to be enable these two pods. It will check how many resources are utilized and how many resources are left, which means CPUs and RAMs. So it will check all these information. It will find, okay, this node is suitable for scheduling this pod. So once it is fine, so it is going to tell, this scheduler is going to tell through the API server to the kubelet. So this kubelet is going to take the input from the scheduler. So scheduler is going to tell to the kubelet saying that, hey kubelet, so I got a request from the API server. So we have to create two pods and each pod should contain one container, which is a Docker container. So kubelet, what it will do, it will take the responsibility and it will enable a pod. It will create a first pod, which is a one pod, and it will create another pod. So creating instead of container in each pod is a responsibility of container runtime, which means like we have installed Docker. So kubelet is going to talk with a container runtime. Here our case is Docker. So it is going to give a commanding to the container runtime as a Docker. So Docker is going to create a container of a container instead of each pod. So this is a container instead of the pod. So this is how, when the user requested to the API server, and this API server is going to communicate with the scheduler, and scheduler is going to find which node is suitable for scheduling this pod, and this scheduler is going to talk through the API server to the kubelet, and kubelet, what it will take this responsibility to create two pods. And when it comes to after creation of pod, so this kubelet is going to give a commanding to the container runtime, and this container runtime is going to create a container inside of the pod. Fine, everything is working fine. And what about the kubeproxy? So the usage of kubeproxy, if you want to make the communication between the two pods, so that is why kubeproxy comes in the picture. So if I want to, let's example, this is a web server. This is a web server, and this is a application server. So I would like to make a communication between the two, between those two parts. So to the kubeproxy, I can make I can use a kubeproxy to make a communication between those two pods. So that is where kubeproxy can be used. And kubeproxy can be used in other scenario also. Let's example, we have another node. Let's example, we have another node over here, and that node is having a, let's example, we have web server over here, and the application server is running on another node. So that case, by using a kubeproxy, we can make a communication between these two pods. Another case, like if you want to get the traffic from user to the pod by using a kubeproxy. So from the services, we have a cluster IP and node port, and we have a load balancer. So from that, all the crashing, all the services. So if you want to make a communication between the user to the pod, so by using a kubeproxy, you can enable that service. So I think we have discussed everything about each level of components and how the user can schedule the pod and how the pod gets created and what components do its job. So that's it for lecture. And if you have any queries, so feel free to drop in comment section. And thank you for watching this video.